Well, well, my cosmic pal, do you ever feel like everything is just drifting apart? Well, your intuition may be right. It turns out something weird is indeed happening in the universe. Since the Big Bang, everything has been spreading out in every direction and getting faster every day. But here's the thing, not all galaxies are moving at the same speed. We have some seriously massive clumps of matter out there that are slowing us down. And there's one giant, mysterious gravitational anomaly that's been dubbed the Great Attractor. No, we're not counting me, though we share the same nickname. It's the mystery of mysteries, and it's been pulling us and all the nearby galaxies closer to it for billions of years. Scientists aren't certain what this great attractor is made of, but it's so powerful that it overcomes dark energy, which makes up about 2/3 of the universe. Dark energy is more or less like the universe's energy drink, pushing everything forward and giving galaxies a boost in their movement. So where is this thing? Hiding in the zone of avoidance, which sounds like a made-up town from a sci-fi movie, but is actually a real place in the universe. There's just so much stuff between us and the Great Attractor, stars, gas, dust, that we can't even see it. Some astronomers think this is just how the universe ends. Everything clumps together into one giant supercluster, and then boom, big crunch. It's like when you're trying to fit all your clothes into one suitcase, and it just ends up exploding everywhere. Now, before you start thinking that galaxies moving is no big deal, let me tell you that this isn't just any ordinary movement. You see, this thing called the Hubble flow dictates that galaxies should be receding from one another as the universe expands. But, as luck would have it, that's not what's happening. The Great Attractor is so strong that it even affects our own galaxy, hurtling us toward it at more than 1,000,000 miles per hour. I'll spare you the math, but if we spun around the sun at that kind of speed, our year would be a mere 18 days long. The Great Attractor was first noticed in the 70s, but our technology wasn't quite up to the task of seeing through the zone of avoidance. Nevertheless, X-ray technology has come to our rescue in recent years, and it has helped us piece together some of these hidden parts of the universe. What can this Great Attractor be, you might ask? We can only make assumptions at this point. The most likely solution is that it's a galactic cluster. They are basically the universe's version of a massive family reunion. These bad boys are held together by their own gravity and can pack hundreds or even thousands of galaxies, along with a ton of hot plasma and sneaky invisible dark matter. Ooh, see. The X-ray data have revealed a plethora of distant galaxies that we previously didn't know existed. Not only that, but 2 new galaxy clusters have been found, the Norma cluster and Shapley supercluster. The Norma cluster has a mass of roughly 1,000 trillion suns and comprises thousands of galaxies. It's possible that the Norma cluster is the reason for the Milky Way's high-speed hurtle through space, but it still can't explain the movement of thousands of galaxies around us. However, when scientists peered deeper through the zone of avoidance, they spotted the Shapley supercluster. This behemoth of a galaxy cluster is the largest within 1 billion light years. It could explain the movement of galaxies in our sliver of the universe. More than 8,000 galaxies create a mass of more than 10 million billion suns. Most scientists have accepted that the Shapley supercluster is most likely the force behind the Great Attractor. It lies in the region where the pull appears to be coming from, and logically, it seems to make the most sense. There's more though. Some researchers take pause at the proximity of the Shapley supercluster to other clusters. Too many galaxies come together in various clusters there, openly defying the Hubble flow. Some experts believe that a large gravitational anomaly is a real answer to the Great Attractor. There have been theories ranging from a supermassive black hole, larger than anything we could possibly imagine, to some sort of life form making a mess in that corner of the universe. The Great Attractor is not the only weird thing we've stumbled upon in the universe, as you can imagine. Have you heard of the Red Rectangle? No, it's not a new dance move, but an amazing nebula surrounding a star called HD 44179. This star is a lot like our Sun, but it's at the end of its life and is spewing out gas and other materials to create this incredible structure. Some scientists think that the star might actually be a close binary, meaning it has a partner, and that there's a thick ring of dust around it. And even though we've got some ideas about how the Red Rectangle got its shape, scientists are not entirely sure. One thing we do know for sure is that the Red Rectangle is a type of nebula called a protoplanetary nebula. And when that happens, there will be a super hot white dwarf star left over, which will give off some seriously cool ultraviolet radiation and make the surrounding gas glow. As for its location, it's about 2,300 light-years away, hanging out in the constellation dubbed the Unicorn. Not all weird space objects are so far away from us in the universe. Some of them may be lurking pretty close to home. In January 2015, two clever astronomers made a prediction that a gigantic planet could be spying on us from our outer solar system. Now, before you start getting too excited, we should point out that they haven't actually seen this mammoth world yet. Their prediction is based on some pretty basic math and computer simulations, so there's still some debate about whether this prediction is true or not. But if it is, this planet, which scientists have nicknamed Planet 9, also called Planet X in the past, could be up to 10 times the mass of our own Earth and about the same size as Uranus or Neptune. What's really unusual about this mysterious planet is that its predicted orbit is extremely elongated, making it unlike any other planet we've seen before. In fact, it's estimated to be about 20 times further from the Sun than Neptune, and it takes between 10,000 and 20,000 years to complete just one full orbit. You might be asking yourself, how can anyone predict a planet they've never seen before? Well, these scientists noticed that at least 5 other smaller objects floating around in the distant parts of our solar system seem to be following similarly unusual orbits. By analyzing these orbits, astronomers worked out that there must be a big, undiscovered planet out there causing all the fuss. To figure out this mystery, astronomers will be peering into the universe's most powerful telescopes to see if they can spot this elusive Planet 9. However, it won't be an easy task, since an object that is so far from the Sun must be very faint and difficult to detect. Some astronauts have even experienced the Bermuda Triangle equivalent of space while passing through the South Atlantic anomaly. This is a region in Earth's magnetic field where 2 rings of charged particles come closest to our planet's surface. And as luck would have it, this area happens to be high above the South Atlantic. Computers can go haywire there, and astronauts can see cosmic flashes, possibly because of radiation stimulating their retinas. And it's not just poor astronauts who have to deal with this anomaly. Even the Hubble Space Telescope is unable to make observations when passing through this region. It's a real pain in the telescope's lens. So, what's the deal with this SAA? It turns out that our planet's magnetic field is not perfectly aligned to its rotation axis, which causes the 2 particle rings to tilt. And as a result, we end up with this region that's causing all sorts of trouble. Well, space is just one thing or another, isn't it? Prepare for blastoff because there's some exciting news from NASA coming our way. Care to look into the fascinating world of Saturn's moon Titan? NASA's groundbreaking Dragonfly rotorcraft lander is set to take off in 2027, looking to explore this mysterious space object. Now, let me introduce you to Titan. It's an icy celestial body with an atmosphere filled with nitrogen, and it might even have an underground ocean. Titan is also home to rivers and lakes that flow on its surface. But guess what? They're not filled with water like our lovely planet. They have methane instead. Now, let's check out Titan's celestial credentials. It's not just any moon, it's the second largest in our entire solar system. It's only 2% smaller than the biggest moon we have hanging around our neighborhood, which is Jupiter's Ganymede. Titan's size even puts Mercury to shame. And did I mention that its atmosphere is 4 times denser than that of Earth's? Thanks to Titan's lower gravity and thick atmosphere, Dragonfly is the perfect robotic companion to uncover its hidden treasures. Let's move on to Dragonfly, the star of NASA's upcoming mission to Titan. This cosmic drone is not your average explorer. Equipped with a full array of interesting gadgets, Dragonfly is like a flying laboratory, ready to uncover more secrets of Titan. It's the first interplanetary rotorcraft lander probe, designed to take us on an epic journey of discovery. And don't let its name fool you. Dragonfly won't just buzz around aimlessly. This technological marvel is able to glide for several miles between different locations on Titan's surface. Think of it as a cosmic Uber service for scientists. And speaking of technology, Dragonfly is carrying some seriously cool equipment. It will feature the drill for acquisition of complex organics, Draco instrument, which will help us scoop out material from Titan, while the Dragonfly mass spectrometer, DRA-MS, will analyze what these samples are made of. But how did we stumble upon Titan? It was March 25th, 1655, when a Dutch astronomer was out there with his telescope, exploring the cosmos. Lo and behold, he spotted something amazing. It was Titan, the biggest moon of Saturn. Fast forward almost 300 years to 1944, when another cool astronomer jumped into the picture. He was doing some experiments with light when he figured out that Titan actually has its very own atmosphere. There's more to this story. In 1979, the Pioneer 11 spacecraft decided to take a joyride through the Saturn system. It confirmed all the cool things scientists had previously speculated about Titan, like its temperature and mass. However, there was one tiny mistake. Those sneaky scientists thought Titan might be the biggest moon in the entire solar system. Oops, wrong guess. Nevertheless, Titan had this mysterious dense atmosphere that kept everyone on their toes. Now, let's zoom in on the 1980s, when the Voyager 1 and 2 spacecraft make their grand entrance. These cosmic explorers flew past Saturn, and they wanted to get a good look at Titan's surface. That's when Titan decided to play a game of hide-and-seek with them. Its hazy atmosphere made it impossible to see what was going on down there, so all the Voyagers managed to capture were images of a lonely orange world. However, they did spot a fancy blue haze hanging out in the upper atmosphere. Things started to get really exciting in the 1990s. The Hubble Space Telescope joined the party and decided to take some cool snapshots of Titan using special infrared light. This clever device managed to pierce through the haze, and voila! The Hubble images revealed differently colored areas on Titan, almost like a giant cosmic chessboard. We now know that there's even a bright spot as wide as Australia down there. However, despite these fantastic pictures, the mystery of what lay beneath Titan's haze was still unsolved. It was 2004 when the stage was set for Cassini and its European sidekick, the Huygens probe. They were like the ultimate dynamic duo, ready to take on Saturn. Cassini started orbiting the ringed planet and immediately focused its attention on Titan. The big moment finally arrived. On January 14, 2005, the Huygens probe pierced through Titan's atmosphere. During its descent, Huygens collected all sorts of amazing data, snapping images and analyzing the atmosphere. The probe then transmitted this valuable information back to Cassini, which, like a cosmic courier, sent it to us eagerly waiting Earthlings. Over the next 13 years, Cassini flew close to Titan over 100 times, using all sorts of fancy instruments to get a good look at the moon's surface and atmosphere. Scientists could finally confirm that Titan had clouds, lakes, and rivers, and there was also some rain pouring down its surface. Thankfully for us, Titan isn't the only moon in our solar system that could technically harbor life. Take the wondrous moon of Neptune called Triton. For starters, it's the largest moon of Neptune, but it's also a real oddball. Among the many moons out there, only 5 are known to be geologically active. And guess what? Triton is proudly part of this exclusive club. It loves to show off its geysers, which spew nitrogen gas. Picture Triton as a fashionista in an icy ensemble. Its surface is mainly frozen nitrogen, giving it a chill, frosty vibe. You might want to bring a warm coat if you ever visit. Now, you may be wondering how Triton manages to keep warm in such a frigid environment. Well, it's got a secret weapon called tidal forces. Imagine Triton and Neptune engaged in a cosmic dance, creating gravitational friction. This dance seems to generate some heat, helping to warm up Triton's waters. With all this talk about heat, you might be getting excited about the possibility of life on Triton. However, finding life on this moon is about as likely as finding a unicorn riding a skateboard. Voyager 2, the only mission to ever fly by Triton, made its journey back in 1989. And if you're hoping for another mission to Triton anytime soon, well, let's just say the stars aren't aligning in our favor. Literally. The window for a mission to Triton opens up only once every 13 years, because our planet and Jupiter need to be perfectly aligned for the landing to work. Scientists would use the gravitational pull of the largest planet in our solar system to safely deliver a probe on Triton. Now, let's address the elephant in the room, or should I say the polar bear. It's so cold on Triton that hopes for life to survive unfrozen are about as slim as a toothpick. Sorry, potential little microbes. You might need a few extra sweaters to set up shop down there. Even though Triton may not be the most welcoming place for life, it's still a celestial gem worth exploring. Scientists also believe Triton wasn't always a part of Neptune's crew. As it turns out, Triton was most likely just minding its business, hanging around aimlessly in the distant Kuiper belt. Along came Neptune with its mighty gravitational pull and snatched Triton right out, officially making it a moon of its own. Just like our trusty satellite, Triton is also stuck in a permanent face-off with Neptune. One side of Triton always has its eyes locked on the planet. As for this amazing moon's fate, things aren't looking so good in the long run. It's already getting closer and closer to Neptune every day. Why is that, you might wonder? The problem is with those tidal interactions, which are playing some cosmic tricks on Triton. They're causing its orbit to wither away, like a slow-motion dance towards Neptune. Scientists predict that in about 3.6 billion years, Triton will cross an invisible boundary. If these current calculations are correct, there are 2 possible scenarios. It'll either have a collision with Neptune's atmosphere, or it might just break up into tiny pieces. If the latter happens, an all-new ring system would form around Neptune, just like the one we see around Saturn nowadays. Triton is not the only satellite that might end up this way. Phobos, one of the Martian moons, is likely to disintegrate too, and sooner, in 30 to 50 million years. Astronomers have recently found a strange object far away from Earth. It disappears every 2 minutes and sends out waves of radio noise 3 times in 1 hour. It was first seen by a student named Tyrone O'Doherty while he was looking at the sky in his home country, Australia. This space object appears to be different from anything else we've seen before in space. Because of their calculated movements, scientists call these types of objects transients. Turns out, they are not that rare to find. When scientists study transients, most of the time, they look near a big star or near the things it leaves behind after it goes out. Transients come in all sorts of shapes and sizes. Some transients are slow, take a few days to appear, and stay around for a couple of months. Other transients are very fast and only appear for a second. But there are not many transients that are in between these 2 speeds. It's what makes this latest discovery very special and unexpected. Speaking of weird things we've found in the universe, the toughest object we know of is made from the remains of a star that has faded away. Scientists have found out through experiments that when the center of a faded star is squeezed by a lot of gravity, it turns in a type of spaghetti-like material that is extremely strong. Even if you could technically touch it with your hand and try to break it, you would need to use 10 billion times more force than it takes to break steel. Planets can be weird too. Haumea is a perfect example. This dwarf planet moves around the sun far away from Earth, beyond Neptune. It's different from other planets because it's shaped like a sausage and has 2 small moons. It also spins very fast. One day on this planet is only 4 Earth hours long. In 2017, scientists saw something strange when Haumea passed in front of a star. They noticed very thin rings around it, which probably appeared when other various space objects were hitting each other in its vicinity a long time ago. Ever heard of a moon? It's a fancy name for a moon that orbits another moon. People on the internet let their creative side go wild with this one and gave it all sorts of different names, like submoon, moonito, grand moon, and moonette. This kind of object is just a theory right now, but scientists think it's possible that it might exist. Maybe someday we'll discover one. There are many strange moons in our solar system, like Io, which is very volcanic, and Triton, which has geysers. But one of the weirdest looking ones is Hyperion. This one is a rocky moon with many craters that looks like a pumice stone. A spacecraft called Cassini also found that Hyperion has a beam of static electricity flowing out from it. The reason for this weird activity is still up for debate. Not all stars behave the same either. When a scientist named Tabitha Boyajian, pronunciation here, https u2.b f8vy3 tians56, and her team looked at this star called K-ICE 846285, they were confused. Also known as Tabby's star, this space object would dim unexpectedly, sometimes for as much as 22%, for random periods of time. However now, most people believe that the star is surrounded by a strange ring of dust that makes it look darker every now and then. Some galaxies are equally unusual. DGSAT I is a type of galaxy called an ultra-diffuse one. This means that it is very big, similar to our own Milky Way galaxy, but it has very few stars and is hard to spot with regular telescopes. Scientists discovered DGSAT-Y in 2016 and noticed that it was all by itself, which is unusual for ultra-diffuse galaxies. This means that DGSAT-I is very old and formed a long time ago, about 1 billion years after the beginning of the universe. NGC 247 is another weird spiral galaxy that looks almost made up. It is smaller than the Milky Way and has bright areas where new stars appear. However, there's also a dark void on one side of the galaxy's core that looks like a hole. Some theories suggest that this void could have been caused by gravitational interactions with another galaxy, or a blob of dark matter. Another theory suggests that it could be the work of another civilization building something weird in there. The Exotica catalog lists some unusual galaxies that might have big civilizations living in them. Scientists are trying to build new telescopes that will make it easier to find them. The Vera C. Rubin Observatory in Chile, for example, will be able to look at the entire sky repeatedly and see if there are any changes that could help us locate some foreign space cousins. Just in case you ever stumble upon this word, a neutrino is a particle smaller than an atom, with no electric charge and a very small mass. They are produced during nuclear reactions, such as those that occur in the sun. Neutrinos are extremely difficult to detect because they interact with other types of matter very weakly. Scientists use large underground or underwater detectors to spot neutrinos. They study their properties to gain a better understanding of the universe and its origins. On September 22, 2017, a powerful neutrino hit Earth. This kind of thing happens often, but this one was special because scientists were able to figure out where it came from. They discovered that it was sent to Earth 4 billion years ago by a very big black hole in a galaxy that was eating up everything around it. Do you think you have an impressive jewelry collection? Wait until you hear this. Astronomers have discovered a planet that is mostly made of diamond. The planet, called 55 Cancri E, is a superplanet and is located in our Milky Way galaxy. Scientists believe that at least a third of the planet's mass is pure diamond. This is the first time a rocky planet with this kind of composition has been discovered. 55. Cancri E is very different from Earth, as it has a lot of carbon and is very hot, making it unlikely for life as we know it to exist on it. We've learned a lot of things about the universe with the help of our trusted Hubble Space Telescope. One of the most famous images taken by it is called the Pillars of Creation. This is a photo of a region of the Eagle Nebula where new stars emerge rapidly. Captured in 1995, this picture allowed us to see massive pillars of gas and dust towering above the nebula, and has become one of the most iconic images of the universe. Some of your friends might even use it as wallpaper on their phones. The sun we spin around is a lone wolf. In reality, many stars in the galaxy have companions. Castor is one of these. It's a group of 6 stars that make up one of the brightest and most beautiful systems in the night sky. People have been looking at Castor for a long time, but they hadn't known it was actually 6 stars until telescopes and spectroscopes were invented. Even with a small telescope, you can see that Castor has 2 main stars, Castor Ea and Ba, that orbit each other. These stars are bigger than the Sun, and it takes them 467 years to orbit each other. Scientists from Asia found over 500 stars that are way weirder than those we've been familiar with. They move quickly around the center of our galaxy, the Milky Way. Some of these stars move so fast that they will, at one point, leave the Milky Way. The team behind the project used 2 telescopes to study these stars and properly understand their speed. These days, we call them high-velocity stars. Jupiter used to be flat and look like an M&M candy, and it wasn't the only flat planet in our solar system. Turns out there are tons of things that can go wrong during a planet's formation, like locking up to the sun or getting whooshed in open space. Let's check it out. The Earth isn't flat, but Jupiter might have been. Instead of being a big round ball, gas giants in our system might have started more like flat pancakes. Jupiter is one of the oldest of our neighbors. It's 4.6 billion years old, just like our Sun, and when it was just a baby planet, it likely formed through a process called disk instability. On 3 sec pause. It all begins with stars. When a star is forming, it doesn't look like a round object. It's more like a big disk of stuff. During this stage, really hot winds made of charged particles blow out. The dust in that disk contains stuff like carbon and iron. Some of them collide and stick together, forming bigger objects. Dust turns into pebbles, pebbles turn into rocks, and rocks bump into each other, getting bigger. Gas in the disk helps all these solid bits stick together. Some break apart, but others stick around, and they're the ones that become the basic pieces of planets. They're called planetesimals. Even gas giants like Jupiter started off as tiny specks of dust smaller than a human hair. Eventually, they formed their own big, ring-shaped disks of gas. They began to spin around our sun, growing bigger by gathering gas and rocks like snowballs. To 2-3 sec pause. Gas giants are special. They were born from the colder parts of the disk. In cold areas, molecules are slower, which makes them easier to grab. In these places, water could freeze, and tiny ice pieces stick together and are mixed with dust. These dirty snowballs gather up and then form cores of huge planets like Jupiter, Saturn, Uranus, and Neptune. In the warmer areas closer to the star, rocky planets like Mercury, Venus, Earth, and Mars start to form. After the icy giants were born, there wasn't much gas left for these smaller planets. It might take tens of millions of years for these rocky planets to form after the star is born. And our sun was growing at the same time, sucking up nearby gas and pushing faraway stuff even farther out. After billions of years, the disk changed completely, turning into a round star with a bunch of planets, dwarf planets, asteroids, moons, meteoroids, and comets around it. A third 3-sec pause. Recently, simulations showed that these protoplanets, as these early dusty balls are called, don't start off looking like the planets we know. In the case of gas giants like Jupiter, they looked more like squashed balls or M&M's candies, not the peanut kind. When the sun was young, the disk of gas and dust surrounding it cooled down and became unstable. It started breaking into big chunks. These chunks dramatically collapsed together under huge gravity to create Jupiter. It became a round gas giant over time. There are a lot of oddities that can happen during that process of planet formation. Ever wonder why Venus or Uranus spin the opposite way compared to other planets? Usually, when things form from a spinning disk of gas, they tend to spin in the same direction. For example, if you spin a bunch of balls on a string, they'll all twirl in the same way. So theoretically, all planets should spin in the same direction too. But there are a lot of fast-moving objects, like comets and asteroids in our solar system. When they smash into planets, especially during their early days, this collision might send the planets to spin in the opposite direction. Venus and Uranus probably survived a massive collision. Luckily, they weren't repelled to outer space. The gravity from the sun and nearby planets pulled them back into place. 4-3-sec pause. There are also so-called tidally locked planets. These are celestial bodies that spin in a way where one side always faces their star while the other side remains in perpetual darkness. So, one side is always very hot while the other is extremely cold. If we were on a planet like that, we would only be able to live on a thin line in between. These planets form when they're very close to their star. The gravitational forces are extremely strong, and over time, these forces slow down the planet's rotation until it matches the time it takes to orbit the star. Imagine you're spinning in your chair. Someone comes up to you and, holding onto your chair with their hands, starts spinning with you. This way, you'll always face each other. Tidally locked planets kind of worked like that. Our moon is tidally locked to our Earth, which is why we only see one side of it. Suffer 5, 3-sec pause. We discovered more than 5,000 planets outside of our solar system, called exoplanets. Some of them have very strange orbits. For example, planets with incredibly long orbits, thousands of years to make one trip around the star, or very wonky, comet-like orbits. Or so-called hot Jupiters, they're super close to their star. Way closer than Mercury is to our sun. But these planets couldn't have formed where they are now. As their solar system evolved, they changed their positions for some reason. This rearranging is called planetary migration. 6 3-sec pause. There are 3 main ways this migration happens. First, because of the gas and dust spinning around the planet. When a planet is bumping into this stuff, it can create spiral patterns in the gas. These patterns can either push the planet closer to the center or farther away, depending on how they mix together. It's called a gas-driven migration. This is what Jupiter experienced when it moved closer to the sun billions of years ago. This also explains the existence of hot Jupiters. Second, big planets can shove the smaller ones, changing their paths. Third, the star's gravity can tug on the planet, making its orbit more circular. S7 3-sec pause. Ever heard of rogue planets? Imagine a lonely planet floating in the vastness of space without a star to call home. They're like the wandering nomads of our galaxy, doomed to drift around forever. And there are so many of them. There might be more free-floating planets than ones that are tied to stars. We're talking trillions of rogue planets hanging out in our Milky Way galaxy alone. They're often as massive as our biggest planet, Jupiter, but most of them might be Earth-sized. Some might even have thick atmospheres that keep them warm. Even though they're far from any star, some of them might have wild auroras, while others could host moons with liquid water. Ait satsam, bombat metro semono comsosat. Ay might persactate sites. For Shmai, there's even a chance that they might contain extraterrestrial life. These planets might bump into other stars, or even entire planetary systems as they journey through space. Sometimes, they might get caught in a star's gravity for a while before getting flung back out into space. But how are they born? Sometimes, during this chaotic process of planet formation, not all planets can manage to stay close to their parent stars. Some of them get kicked out of their solar systems due to powerful gravitational interactions with other planets or passing stars. These ejected planets become rogue planets. This 3-sec pause. In 2012, astronomers found a solar system from the very beginning of the universe. This system included a star and 2 planets. We called it a fossil system. The star is super old, about 13 billion years, almost as old as our entire universe. It was mostly made of just hydrogen and helium. About a year back, something wild happened on Mars. Its magnetic shield and air around it expanded to about 3 times the usual size. Earth has experienced this ballooning before too, in 1999. It caused our magnetosphere to expand up to 100 times its usual size, and scientists are saying that Earth might experience it again soon, but on an even larger scale. The consequences of that could be catastrophic. Let's see why it happens, and what might happen to us if that repeats. NASA's MAVEN orbiter has been orbiting Mars since 2014. It's the only spacecraft we have that keeps track of both the Sun and Mars. In 2022, on December 26, it witnessed a fascinating show on the red planets. Mars' atmosphere and magnetic shield suddenly stretched out by thousands of miles. According to scientists, it's a unique, unbelievably dramatic event, and MAVEN was there to catch it all. Scientists tried to uncover this mystery. Digging into the event, they discovered something incredible. It turns out this airshow was linked to the solar winds. Solar wind is the stream of particles coming from the sun. It's a constant flow of protons and electrons from our star's outer atmosphere. Moving super fast, up to 804 kilometers per second, these charged particles travel through the solar system in a plasma state. Mars, like all the other planets in our solar system, is always dealing with solar wind. Think of it like a breeze from the sun. This wind pushes on Mars's magnetic shield, called magnetosphere, and is part of why Mars loses some of its atmosphere into space. Researchers found out that the weird expansion on Mars happened because there was a rare void in it. Faster solar wind caught up with slower solar wind, making them squeeze together. This created a gap in part of Mars's atmosphere because some solar wind was missing. This unusual situation caused Mars's magnetosphere to expand so rapidly. The Sun goes through a cycle about every 11 years. It jumps from low activity, or solar minimum, to high activity, or solar maximum. Then it jumps back. We noticed this way back in the 18th century, and we're currently on the 25th cycle. It's all because of the Sun's magnetic field. During solar minimum, the magnetic field is strong and organized, but over time, it weakens. Suddenly, solar activity jumps up. This creates solar winds, the sun spewing jets of particles on the planets, including our Earth. In 1999, the solar wind nearly disappeared for 3 days. It will probably repeat again now. This time around, scientists believe it might hit us sooner and harder than expected. The sun becomes quite lively, emitting fiery plasma, developing large dark spots, and releasing powerful radiation. And unfortunately, the upcoming solar maximum kind of caught us off guard. The storm was predicted for 2025, so scientists aren't very prepared. The number of sunspots observed has been way higher than anticipated. The sun hit an 8-year sunspot peak in 2022 and then showed more than double the expected sunspots in 2023. And it's not just them. Solar flares have also been on the rise. In March, the geomagnetic storm lighted up the skies with vibrant auroras across 30 US states. It was the strongest storm in over 6 years. Many rare solar events have become more common recently. For example, a gigantic plasma waterfall, a polar vortex swirling around the sun's north pole for hours, and a 3-day solar tornado towering over 14 Earths. Because of all that, Earth faces some risks. Solar storms could hit our planet, it can mess with communications, damage power systems, and cause blackouts, and even pose threats to living beings. They can ionize Earth's atmosphere. This would mess with radio signals and GPS systems. Major disasters, like earthquakes or tsunamis, combined with such blackouts, could lead to catastrophic outcomes. Additionally, strong solar storms may generate electrical currents that can damage infrastructure, including power grids and rail lines. Airplane passengers might experience higher radiation levels during solar storms. It's hard to tell what that would mean for their health. However, astronauts on spacecraft, such as the International Space Station, could face more significant risks. Future space missions will have to take solar cycles into account. We're not the only creatures in danger. These storms can disrupt the migration patterns of animals like gray whales, sea turtles, and birds. All these poor animals rely on Earth's magnetic field to understand what's going on. And, as a cherry on top, there's a risk of satellite collisions. Commercial space companies are focused on launching satellites quickly rather than safely. Because of that, they often overlook the impact of space weather. During solar storms, the ionized upper atmosphere increases drag on Earth-orbiting satellites. If something goes wrong, satellites can be forced out of orbit and collide with us. The scariest solar storm that has ever happened to us was the Carrington event. In 1859, Earth experienced the most intense geomagnetic storm ever recorded. The sky lit up with vibrant auroras. They were visible from the North and South Poles to places like Cuba and Japan. The display was so bright in the United States that gold miners woke up thinking it was morning. It was caused by a massive solar flare. The auroras were breathtaking, but the impact was more than visual. It disrupted telegraph systems across Europe and North America. Telegraph pylons threw sparks, operators got electric shocks, and conversations were conducted using the auroral current instead of batteries. Similar storms occurred at least 3 times throughout history, with the same awful consequences. Scientists estimate the cost of such an event today could range from $600 billion to $2.6 trillion in the US alone. Researchers continue to study historical events and ice core data to understand and prepare for the potential impacts of future solar storms. The sun's behavior is very unpredictable, but this just shows that we need to study it in greater depth. The chance that this new coming storm will be the same as a superstorm like the Carrington event is low. Besides, if we spend this time preparing, it might go unnoticed. Preparation usually involves adjusting satellite trajectories, grounding planes, and identifying vulnerable infrastructure. Meanwhile, we keep exploring Mars. Its atmosphere is different from ours. Our atmosphere has breathable air, mostly consisting of nitrogen, oxygen, and a lot of other gases. Meanwhile, Mars has incredibly high CO2 levels. If on Earth carbon dioxide doesn't even reach 1%. On Mars, it makes up about 96% of its atmosphere. Also, Earth's atmosphere is over 100 times denser than the one on Mars. Even though Mars is about half the size of Earth, Its atmosphere is like a feather compared to our air. But it wasn't always this way. A long time ago, Mars could have been kind of Earth-like. We know that it definitely had water, and perhaps there even were some plants. If we added water on Mars now, plants could have grown up there. A long time ago, Mars was experiencing some serious volcanism, suggesting it had a thick atmosphere and maybe even a giant ocean. We're not sure what happened to them, but there are some theories. For example, Mars has a magnetic field, but it's very weak, so solar winds could have stripped away its atmosphere. In the end, it became the chilly, dusty red planet we know today. NASA's Perseverance rover celebrated its 1,000th day on the red planet with some amazing discoveries. The rover cruised through an ancient Martian river and lake system. It gathered 23 precious samples along the way. All of these samples will help us to unlock Mars's history and geological mysteries. Extreme events and conditions are horrifying, but great in a way that they help us to learn more about our solar system. Luckily, Maven was designed to be sturdy and prepared even for intense solar storms, so now we can find out more about Mars when it's stripped of its protectiveness. Shot pirate. Arr! Hold onto your telescope, space rat. Scientists have made an astonishing discovery. They've found the ancient heart of the Milky Way galaxy. But what is this ancient heart? And what does it tell us about the history of our galaxy? Let's find out. Ketchunau retroskau, chatue purisei, our chassis datiers, chatis errors, chain site service. Pirate, is that it? Dawn, yes, and thank you, Captain Jack. Pirate, my pleasure. He leaves. That's right, what can I say? He's a space pirate. The Milky Way isn't just a candy bar, but a majestic spiral galaxy that's home to billions of stars, planets, and other celestial objects, and it's all spread out over a distance of about 100,000 light-years. The Milky Way has a distinct shape, with a central bulge and spiral arms that extend out from it, kind of like what I look like from the side. The spiral arms are like the suburbs, where the stars are more spread out and the neighborhoods are quieter. They're made up of gas, dust, and stars that all move together in a circular pattern around the center. In between the spiral arms, there are vast regions of empty space, known as interstellar space. Here, you can find wispy clouds of gas and dust, as well as some of the most spectacular sights in the galaxy, like massive star-forming regions and colorful nebulas. The Milky Way is also surrounded by a huge halo of dark matter, a mysterious substance that we can't see but can feel its gravitational effects on the galaxy. This halo helps to hold the galaxy together, and it extends out much farther than the visible parts of the Milky Way. And finally, there's the center. Here, the most action happens. In the center of the Milky Way, there is a supermassive black hole, which is about 4 million times more massive than our Sun. Sagittarius, a star. This black hole is responsible for some of the most energetic events in the galaxy, like the emission of powerful jets of energy. Remember the famous first photo of a black hole that flew across the internet? It was Sagittarius, a star. We managed to capture this black hole because it's the closest one to us. All in all, the center of the Milky Way is full of stars that are tightly packed together, forming a dense cluster. And it was here that astronomers recently made a new epic discovery. The heart of our Milky Way galaxy has been found. And boy, oh boy, is it an old-timer. Hey, who are you calling an old-timer? A team of brilliant scientists has found a cluster of 18,000 stars, born right after the Big Bang. Together, they form the ancient nucleus of our Milky Way. These stars date back to a time when our galaxy was just a wee little baby, a mere collection of proto-galaxies, huddling together to form a bigger and better thing. The scientists called it the poor old heart of our Milky Way. Can you believe it? These ancient stars are over 12.5 billion years old. And yeah, maybe they account for a mere 0.2% of our galaxy's total mass. But that doesn't matter. These stars are the building blocks that formed the core around which all the other stars and planets took shape. But how exactly did they become this heart of the galaxy? How did they form? And how did we discover all that? To answer these questions, we'll have to plunge into the past. A very, very distant past. Once upon a time, almost 14 billion years ago, there was the Big Bang. Our universe was born. At first, it was incredibly hot, but as time passed, things started to cool down, and tiny pockets of gas began to clump together due to the force of gravity. These were the first galaxies. The Milky Way is one of these galaxies. It also started as a small clump of gas and dust, but over time, it began to take shape. The very first stars, protostars, began to form within the clouds, and their gravitational pull caused more stuff to come together. This process continued for millions of years until the Milky Way was formed. But to learn the history of our galaxy in more detail, we need to find these protostars. And this is far from an easy task. Researchers have discovered the ancient heart, using a neural network to analyze data from the European Space Agency's Gaia mission. The Gaia telescope is a space observatory launched by the European Space Agency in 2013. Its job is to map the position and movement of more than 1 billion stars in the Milky Way galaxy. 1 billion stars. That's like counting every grain of sand on a beach. It's a huge job, but Gaia is up to the task. So, how do they do it? The telescope has 2 cameras that take pictures of the sky at the same time. These cameras are so powerful that they can detect stars that are 1 million times fainter than those visible to the naked eye. Gaia takes many pictures of each star, and this allows it to track their movements with incredible precision. Thanks to the data collected by Gaia, astronomers are learning more about the structure and history of the Milky Way. They're discovering new details about the stars, including their ages, temperatures, and chemical compositions. Gaia is also helping astronomers search for exoplanets, or planets that orbit stars outside of our solar system. So, for this research, astronomers use Gaia and the most accurate 3D map of the Milky Way ever compiled. They had to analyze around 2 million stars to find the primordial group. One way that astronomers can determine the age of stars is by looking at its brightness and temperature. This way, they study a brief phase of stellar evolution known as subgiants. But imagine searching through the huge center of the Milky Way for the tiniest group of stars that are older than 12.5 billion years. This is like searching for a needle in a haystack. Luckily, they had a trump card up their sleeve: metals. You see, in the early universe, the cores of these stars were so hot and dense that they were able to smash atoms together to form heavier elements. These heavier elements are called metals in astronomy, even though they're not really metals like the ones we're used to. The more massive the star, the more metals it can create during its lifetime. When the life of the first stars came to an end, they made a big boom and scattered these metals all around. Metals mixed with other gases and joined the newborn stars, and so on. As time passed and the universe got older, more and more generations of stars formed, each one richer in metals than the last. Can you guess what that means? The older the stars, the less metals they should have. So now it was time for some galactic archaeology. The team taught the AI to find the metal-poorest, most ancient stars, and it succeeded. It found a huge cluster, and all of them were within 30,000 light-years from the center of the Milky Way. Then, they separated out the stars that formed the ancient heart from the stars that originated in a dwarf galaxy, and finally, we were left with the original stars around which the Milky Way grew. This discovery is incredible, It reveals the remnants of the Milky Way's earliest history. It turns out that simulations of the Milky Way's formation were spot on. The old stars existed just where they were predicted to be. Just imagine, the stars that remember our universe as a baby are still hanging out in the center of our galaxy. Isn't that mind-boggling? So why is this such a big deal? By studying these ancient stars, scientists have discovered some incredible things. For example, they've confirmed that the Milky Way's core began its life stationary and only picked up rotational speed as it grew. In 2017, a strange object was spotted in our solar system. It had the shape of a long tube, similar to a pancake. No known asteroid or comet we've seen looks like that. Its exterior was also peculiar. It was at least 10 times more reflective than the average stuff that flies through space, with some saying it had a surface similar to polished metal. When it went past the sun and left our reach, it accelerated faster than what our gravity could account for. At first glance, it was like this thing had a rocket strapped to its back. This unusual visitor even got a special name, Oumuamua, O Muir Muir. It comes from Hawaiian and translates to scout or visitor from a faraway land. And because of its characteristics, scientists soon began to wonder if this was at last a visit from otherworldly creatures. 13 sec pause. Before they went full-on with the science fiction suppositions, astronomers gathered the information they were sure about, starting with the fact that Oumuamua must have come from another solar system. There must have been some unfortunate event in its home system that led to its ejection. What they didn't know was if this was a comet or an asteroid. They're both celestial objects orbiting a sun, but they have distinct compositions and behaviors. Comets are composed primarily of ice, dust, and rocky material, often referred to as dirty snowballs. When a comet approaches the sun, the heat causes the ice to vaporize, releasing gas and dust particles into space. This creates a bright glowing tail that can extend for millions of miles. Comets generally have elliptical orbits, often taking them from the distant reaches of the solar system closer to the sun. 3 sec pause. Asteroids, however, are mostly made of rock and metal. In our neighborhood, they are remnants from the early formation of the solar system and are typically found in the asteroid belt between Mars and Jupiter. Unlike comets, asteroids do not develop tails when they approach the sun, as they don't have ice. Their orbits generally follow more circular paths compared to comets. By all accounts, Oumuamua should be a comet because it seems to come from a different location in the universe, yet it doesn't exhibit the typical signs of cometary activity. Wait a minute, am I doing a commentary on cometary? Nah, never mind. Oumuamua lacks a tail and does not spew out gas as it passes by. Not like me. Even though it behaves like a comet, it looks more like an asteroid. I'll 3 sec pause. Another big question is how scientists even managed to spot Oumuamua in the first place. Considering the vastness of space and time in the galaxy, it's remarkable. Stars have lifetimes spanning millions or billions of years, and the formation of a solar system takes hundreds of millions of years. Even the fastest objects take tens of thousands of years to travel from one star to another. In contrast, humans have only been observing the skies with telescopes for around 400 years, a tiny fraction of cosmic time, and it's only in recent decades, even years, that we've had the technology to detect and track fast-moving, dim objects. Either rocks like these are abundant, or we've been incredibly lucky with our detections, or it simply wanted to be seen. 3 sec pause. Another question that was asked was where such objects could come from. It's highly unlikely that Oumuamua came from a mature, stable solar system. That's because such systems don't eject enough material to fill up the galaxy. Occasionally, a random rock might get flung out, but it can rarely travel so far. Young systems, however, act differently. In these chaotic environments, Collisions, mergers, and migrations are happening everywhere. Plenty of tiny rocks roam around, perfect candidates for ejection. The solar system that kicked Oumuamua out must have had a planet similar to Jupiter. Its massive size and gravity could influence other objects in the system, causing potential ejections. But not all solar systems develop Jupiter-sized planets. Often, massive planets end up close to their stars, becoming hotter versions of Jupiter. These planets, snugly orbiting a sun, are less likely to eject debris. Neptune-like planets might play a role too. While not as massive as Jupiter, they tend to call the outer regions of solar systems their home. Our solar system has the Kuiper belt, a reservoir of comets, in its outer reaches. During a solar system's early stages, interactions between Neptune-like planets and debris are common. Finding Neptune-like planets in other systems has been challenging, though. Our methods for detecting exoplanets work better for massive objects close to their stars, making it difficult to spot Neptune counterparts farther out. A 3-sec pause. Oumuamua was also linked to a peculiar theory about how life came to be in the universe. Panspermia. It's a hypothesis that suggests life exists throughout the universe and can be distributed between planets by various means, such as asteroids, comets, and even spacecraft. It says that life must have originated in one location in the universe and then spread to other celestial bodies. Fans of the panspermia theory have suggested that such interstellar objects could potentially carry tiny microbes, those building blocks of life between star systems. If such objects were to impact a planet or a moon, they could transfer these materials and seed the celestial body with life. For now, there is no evidence to support the idea that this comet in particular has transported life between star systems. Auker 6, 3-sec pause. After years of research, the overall consensus became that Oumuamua was indeed a comet. The reason why it moves strangely is because it might have frozen hydrogen on its surface that reacts when touched by sunlight. The closer it got to our sun, the faster it became, releasing that hydrogen, and also changing its path through our solar system. Its color also supports this theory. It's red, which might mean it's been hit by cosmic rays for a long time. The longer it was touched by those rays, the more hydrogen it gathered in the process. But since they can't be completely sure, astronomers have a plan to follow this visitor. One idea is to send a mission to check it out. It's already far away from us, but it may not be too late just yet. We may be able to send a probe fast enough to catch up with the comet. The plan was named Project Lyra and aims to use the Earth's orbit and that of Jupiter to bounce out a probe far enough to reach Oumuamua. If it works, it will be the fastest space device we've sent out in the universe. One potential trajectory of the space probe involves using the gravitational pull of our planet and that of Jupiter as a lasso effect, but not Ted Lasso. The probe will leave our planet and re-enter Earth's orbit before sending it to meet with Jupiter's pull. It will be sent back near our planet a second time, where it will be ejected with enough force to reach the comet. Second 3-sec pause. Project Lyra also aims to follow a second faraway visitor named Borisov. This one was discovered by an amateur astronomer and now bears its name. What's interesting about it is that, well, it's spotless. Similar to our experience with Oumuamua, we haven't seen anything like Borisov before either. Studies of the light coming from its cloud of dust and gas show it's very clean compared to other space objects. Hundreds of millions of rocks orbit the sun within the asteroid belt between Mars and Jupiter, but only some of them come relatively close to Earth. NASA classifies asteroids orbiting within 48 million kilometers of our planet as near-Earth objects, NEOs. And inside this group, there are particularly worrisome objects. Those are so large and orbit so closely to our home planet that they could turn into a real threat to the world should a direct collision occur. At the moment, NASA is keeping a close eye on an asteroid named Bennu. It's a fairly large space object, Y6610 FT across, that might smash into our planet in 159 years. According to experts, the asteroid, which was first spotted in 1999, is quite likely to drift into the orbit of our planet. If it happens, it might collide with Earth by the 24th of September, 2182. Asteroid Bennu is thought to be taller than the Empire State Building. If it hits our planet, the collision will release 1,200 megatons of energy. That's an enormous amount of energy that nothing built on Earth could produce. Scientists from NASA believe that, during the flyby in the 22nd century, there is a tiny chance that the asteroid will pass through a gravitational keyhole. That's a region of space that might set the space traveler on a certain path, which could result in the asteroid crashing into Earth. Bennu flies by our planet every 6 years. It has had 3 close encounters with Earth, in 1999, 2005, and 2011. These days, scientists estimate the chance of the asteroid hitting our planet by 2182 as 1 in 2,700. That's more than 5 times a person's chance of being struck by lightning. But even though Bennu's chances of colliding with might come as close as 7.5 million kilometers from Earth, that's the reason why it's also classified as a near-Earth object. Bennu is a carbon-rich asteroid that formed in the first 10 million years of the history of the solar system. That's around 4.5 billion years ago. No wonder this space body holds precious clues to the origin and development of the rocky planets of our solar system, which are Mercury, Venus, Earth, and Mars. Even better, it may contain organic molecules similar to those that are crucial for life to evolve. In 2020, NASA's OSIRIS-REx, Origins, Spectral Interpretation, Resource Identification, and Security Regolith Explorer managed to briefly touch the surface of the asteroid. It collected some sample space rock afterward. For NASA, it was the first mission of this kind, but it won't probably come as a surprise that Bennu isn't the only asteroid we should worry about. Asteroid 99942 is another space body we'd better watch out for. It's a near-Earth object about 335 meters across. It was discovered in 2004, and at first, it was identified as one of the most dangerous asteroids ever detected. Apophis gained notoriety very fast. It was believed to pose a serious threat to Earth. Experts predicted that it would come uncomfortably close to our planet in 2029. Luckily, after a more careful examination of Apophis and its orbit, astronomers concluded that there was no risk of the asteroid colliding with our planet for at least a century. The risk of an impact in 2029 was ruled out completely, as well as the potential impact that could be caused by the asteroid's close approach in 2036. Interestingly, until March 2021, there was still a small chance of a collision in 2068. But then, Apophis made a flyby of Earth, and astronomers took this chance to use powerful radars to estimate the asteroid's orbit around the Sun more precisely. This allowed them to rule out any impact risk for at least the next 100 years. Now, the reason why such discoveries make us so worried is that even a relatively small asteroid, the size of a house, can wreak havoc upon colliding with our planet. And if an asteroid is larger than 1 kilometer across, astronomers call it a planet destroyer. The impact energy released by such an asteroid after striking Earth could be devastating. That's why knowing where such asteroids are and in what direction they are moving is crucial. The problem is that our capability to protect the planet from asteroid impacts is not top-notch yet. If such a catastrophe was about to occur, we would need pretty much time to prepare, because an asteroid collision is no joke. Probably the most well-known asteroid impact site is the Chicxulub crater. It's the evidence of the terrifying collision that led to the extinction of dinosaurs. Strangely, this crater isn't very visible, but some others are. For example, Barringer Crater in Arizona, which is also called Meteor Crater. It looks rather blood-chilling when you think about the collision that led to its appearance. In any case, we now know that space rocks hit not only Earth, but also the Moon, Mercury, and Mars. No rocky planet in the solar system is safe from asteroid impacts. That's why we have an entire scientific enterprise whose goal is to find and catalog the asteroid population of the solar system. It might sound a bit scary, but there are around 25,000 asteroids larger than 140 meters in diameter near the orbit of our planet. Such a space rock is large enough to wipe an entire city off the face of the Earth. So far, less than 50% of such asteroids have been detected and tracked. There are also an estimated 230,000 objects equal to or larger than 49 meters in size. Those are capable of destroying a concentrated urban area. And still, fewer than 8% of those have been detected. There are also tens of millions of smaller, near-Earth objects. They are larger than 10 meters across and might cause some surface damage. Less than 1% of such small space bodies have been discovered so far. The thing is, the inner solar system is extremely challenging for asteroid search. Each night, there are only two 10-minute windows when astronomers can observe the region, all because the sun's glare creates a very bright background glow. Plus, the atmosphere of our planet also distorts and blurs observations. Spotting asteroids in such conditions is beyond the capabilities of most telescopes. A really unique instrument is needed to fulfill this task, and the tool of choice is the Dark Energy Camera, DEC, at Cerro Tololo Inter-American Observatory in Chile. This device wasn't designed to hunt asteroids. Researchers built it to search for another elusive target, dark energy, the mysterious force driving the expansion of the universe. The DEC is supposed to observe hundreds of millions of galaxies. That's why it's both wide and deep. This way, it can both peer deep into the universe and capture a wide field of view, which helps it record the motions of galaxies and the conditions in the early age of the universe. But it also means that the DEC is perfectly suited to spotting asteroids near the sun. Inner asteroids are rare, and deep images are necessary because such asteroids are faint. Scientists need to be able to fight both the bright twilight sky near our star and the distorting effect of Earth's atmosphere. And the DEC can help them achieve their goal. The Dark Energy Camera was built to carry out the Dark Energy Survey, which finished in 2019. Now, astronomers can direct the power of the camera toward other tasks. They claim that the DEC survey is one of the most sensitive searches ever performed for objects near Venus's orbit and within the orbit of our planet. It provides us a great chance to find out what kinds of objects are lurking in the inner solar system. Traveling to space costs a fortune, but there's a way to make it affordable. You step into an elevator, push the button, and voila, you're flying to the stars. All thanks to nanotubes. But then, something hits the elevator on the way. You're stuck inside, and you're now doomed to float in space forever. Now, if you want to travel to space, get ready to shell out around $55 million. But in the near future, you will probably be able to travel to space with just the push of a button without breaking the bank. Because space elevators might come into play. While the idea of galactic lifts seems like something out of a sci-fi movie, it is a real possibility that could revolutionize space travel. With an estimated cost of $8 billion, space elevators could be a one-time investment that would last us forever. Biting Whitejut's 3-second pause. NASA alone spends around $2.7 million on rocket fuel per minute. To launch a rocket, they need to pay up to $178 million. These costs could be significantly reduced with the use of elevators. Most super tall buildings on Earth have a massive foundation to help with their balance and weight. As you look up, they get thinner and thinner. Even the tallest building in the world, Burj Khalifa, is massive at the bottom and narrow at the top. If we wanted to construct something like a gigantic lift, we would need an enormous amount of concrete to build a foundation for it, which goes against the point of saving some cash. Now, get a string, tie a ball at the end of it, and start spinning it. The string in your hand will stay in one place, and the ball will revolve around your hand. This is called centrifugal force, and the elevator will work in the same way. The ball will be the base in space, and the rope will hang toward Earth. 3-second pause. The station where we would enter the elevator would be in the middle of the Atlantic Ocean, and the line would extend from there. For this to be possible, the line must be perfectly synchronized with Earth's rotation. Otherwise, it would simply break or wrap around Earth like a scarf. Also, the orbit the line would be following should be a perfect circle because the line wouldn't be able to get shorter or extend. A bunch of research has been done using algebra to find the ideal solution. Wait a minute, there's a use for algebra? Never mind. Meanwhile, I won't bore you with math. We will go straight to the point where the precise distance from the station in the Atlantic to the one in space must be 36,000 kilometers above Earth, where the geosynchronous orbit starts. There, the four outward forces are much stronger than the downward force. That's why the station would stay in one place. When you construct a house or a building, you start from the bottom, going up. But to create this engineering wonder, we would need to do everything in reverse and start at the top. The main problem here would be the weight. If the line was too heavy, it would disrupt the orbit and the conveyor dumbwaiter hoist would not work. So, we'd need to balance the station in space to ensure it worked flawlessly. The 3-second pause. Steel is one of the most robust materials on Earth. The cable in every lift is made from steel, but when you need a 36,000 kilometers long cable, things can get tricky. Steel is hard to break, but it's cumbersome, and when you have to use a lot of it, problems start to arise. We use heavy steel a lot in construction, but we have lighter materials that might put less stress on the station and eliminate this problem. Also, the line would have to be tapered because at the end point, there would be close to zero stress. But it would still have to be thicker than really needed due to a bunch of safety factors. At the start, the rope would be around 0.13 centimeters. After using some complicated math, we can figure out the thickness at the end, which is a number so long that I am unable to pronounce it. But, believe me, it's a big one, so steel is off the list. Another candidate is Kevlar, which is 5 times stronger than steel. And if we added such materials as carbon and titanium into the mix, the strength would increase tenfold. The line would have a diameter of around 80 and 170 meters. This is drastically smaller than the diameter of the steel cable could be. The bad news is that doing this is too pricey. So, if we don't find the ideal medium to build the cable, the idea of the space elevator will be just a massive waste of time. Des 4, 3-second pause. If only we had some magical light material with a power of 60 gigapascals, which would also have a taper ratio of 1.6. Oh wait, we do actually have this unique material. It is called carbon nanotube. It has a strength of 130 gigapascals, which is much more than we need. Nanotubes are made out of carbon and are 100,000 times thinner than human hair. This material is solid and has good conductive power, which is possible thanks to its unique atomic structure. We use this product in many things, from batteries to optics. And it can be modified entirely and adapted for more uses. 5 3-second pause. Bradley Edwards is the guy responsible for this crazy idea. NASA was looking for new innovations, and they said, don't do anything too crazy and start building a space hoist. I guess Bradley took this as a challenge and started working on the elevator. Edwards wrote a paper about a galactic conveyor. When he published it, he expected many people to find flaws in his work, but surprisingly, nobody did. His work was spot on. He came up with the idea of strapping a nanotube line to a rocket and launching it into space. The other end of the rope would fall onto Earth, and robots would use this rope to climb up and make it longer so that we could start building an elevator space station. After this, the elevator could start transporting everything, from solar panels to tourists. Space tourism could be totally possible. Who knows? We might even go on vacations in space. Radio guy. Hey, looking for some atmosphere for your getaway? Well, don't come here. We don't have any. Oops. Probably not a good advertising slogan, huh? A couple of years ago, we could only create microscopic carbon nanotubes. But as time progressed, much more research was done to make them bigger. Now, they reach up to a few inches. In 20 years, they could be miles long. Carbon costs $28 per ounce. If we do the math, we would see that we'd need around $1 billion to build the lift. Yeah, it sounds expensive, but it's a long-term solution to space travel, and it can actually save us a lot of money in the long run. Everything looks perfect on paper, but NASA's main reason why they chose not to go along with this project is that right now, there are probably more than 128 million objects floating in orbit, and they might pose a real threat to the elevator. The lift could be made to withstand a few hits now and then, but getting hammered non-stop is not part of the plan. Still, Bradley argues that tons of monitoring devices track space debris. Thus, the elevator could avoid them all. 7 3-second pause. If something hit the elevator or the line somehow broke, the consequences would not be too bad. If there were no passengers on board, of course. If the line got cut, the elevator would simply float away into space, posing no threat to people on Earth. In Japan, engineers are trying to build a space elevator. The lift could be used for space mining too. We could easily cover the cost of the entire elevator by collecting asteroids because some of them are made of expensive metals. We could mine them and quickly bring them back to Earth. Well, we've been miscalling Uranus all this time. Astronomers say we should be pronouncing it like urine-ass, not Uranus. I can't say a different stress changes much though. However, things could have been different. Initially, Uranus was supposed to have the majestic, king-like name of George, because astronomers wanted to name it after King George III. In the end, they changed their minds, and now, it's the punchline of every joke. If you take the total cost of launching a mission and divide it by the weight of the cargo, you'll see some pretty mind-blowing figures. According to specialists, back in 2016, it used to cost $10,000 to send just 1 pound of cargo into space. But now, prices have gone through the roof. Cygnus spacecraft's cargo costs over $43,000, while SpaceX's new carriers come in at around $27,000 per pound. Remember how hard it is to pay $5 for water at airports? Now, a bottle of water in space would cost somewhere between $9,100 and $43,000, and that's only to have it delivered in space. As for water in space, well, it used to be considered a super rare thing, but in reality, there's water ice all over our solar system, so you don't have to buy those overpriced $43K water bottles. It's hanging out in comets, asteroids, and even in hard-to-see craters on Mercury and the Moon. We're not sure if there's enough water in these places to support colonies of people, though. Mars also has ice at its poles, hiding under its surface dust and frost. Even smaller celestial bodies, like Saturn's moon Enceladus and dwarf planet Ceres, have ice. NASA scientists think there might be a chance of finding life on Jupiter's moon Europa. There may be liquid water beneath its icy shell. Europa, even though it's a lot smaller than Earth, might have an ocean deep enough to hold twice as much water as all the oceans on our planet combined. And in 2009, scientists exploring a massive cloud of gas and dust in the center of our galaxy stumbled upon a fascinating surprise. They found ethyl format within the cloud. This chemical is responsible for the delightful flavor of raspberries and has a rum-like scent. Furthermore, another nearby region is brimming with ethyl alcohol, the same type found in many beverages. In fact, there is enough alcohol in this region to provide every person on Earth with 300,000 pints of beer every day for the next billion years. But believe it or not, but we do have a black hole on Earth. The thing is, creating an in-lab black hole was a sorta indispensable thing to do. Studying black holes in real space remains a distant dream, so it was only possible to create one to experiment with in a lab. A group of scientists in the Netherlands wanted to explore the mysterious Hawking radiation theory proposed by the iconic Stephen Hawking. Using atoms to mimic an event horizon, they orchestrated electrons, causing a surge in temperature that resembled flat space-time. As particles moved through quantum fluctuations, a ring of infrared radiation appeared around the lab-grown black hole, mirroring Hawking's idea. Grown black hole, mirroring Hawking's idea. It may sound insane, but you can totally be allergic to the moon. Long story short, it was the final Apollo mission, and they brought back more rock samples than ever before. Plus, they had the first and only pro-scientist on the moon, Jack Schmitt. He was a geologist, and his rock samples helped scientists learn more about the moon's magnetic field and volcanic history. During the expeditions, it became evident that Jack Schmidt was allergic to moon dust. The gritty, sticky powder clung to his suit and his skin, causing irritation in his sinuses, nose, eyes, and throat for a couple of hours after he took his helmet off. Neutron stars are extremely dense, being basically just a bunch of neutrons squished into a super small space. If you had just a teaspoonful of this stuff, it would weigh more than the entire human population combined. And to match the density of a neutron star, we'd all have to squeeze into a space the size of a sugar cube. No thanks. And when it comes to outer space, we tend to think that Earth and the Moon are pretty close together. But in reality, you could actually squeeze all the other planets of our solar system between Earth and the Moon. The average distance between them is about 384,000 kilometers. If you added up the diameters of the 7 planets, you'd still have some room to spare, about 8,000 kilometers. In 2011, scientists made a groundbreaking discovery of a massive reservoir of water in space. This water, equivalent to 140 trillion times all the water in Earth's oceans, could provide each person on our planet with a planet's worth of water 20,000 times over. This reservoir was located near a massive black hole, drawing in matter and emitting energy, known as a quasar. The water was formed by energy waves colliding hydrogen and oxygen atoms together, and it was found around 12 billion light-years away. When Curiosity Mars rover snapped its very first sunset pic in 2015, scientists were practically doing backflips from excitement. Turns out, sunsets on the red planet are anything but red. They're actually a stunning shade of blue. According to NASA, the reason behind this phenomenon is that the dust in Mars's atmosphere is like a magical filter that lets blue light shine through while blocking out those warm tones like yellow, orange, and red. Venus is a slow spinner compared to Earth. It takes this planet 243 days to make a full rotation, and it spins in the opposite direction. But even though Venus takes longer to spin around, it zooms around the sun in just 225 days because it's located so close. So, believe it or not, a year on Venus is actually shorter than its day. I chose 12. You might think that the night sky should be full of stars with no dark spaces at all. This idea is known as Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers. He thought that if the universe was infinite, unchanging, and timeless, then we should see stars everywhere we look. But it turns out that the universe is not infinite, unchanging, or timeless. Edwin Hubble discovered that the universe is actually expanding, and the leftover radiation from the Big Bang tells us that the universe is about 13.8 billion years old. Think of all the birthday candles. So, the reason we don't see stars in every direction is because some stars are just too far away, or they haven't been around long enough for their light to travel all the way to us. During the Apollo 16 lunar mission, Ken Mattingly, the command module pilot, had a bit of a scare when he realized his wedding ring was missing. The whole crew frantically searched the spacecraft for it, but no luck. Finally, on day 9, while Mattingly was on a spacewalk, the ring was spotted floating out the hatch door. Charles Duke Jr. tried to grab it, but missed. Luckily, it bounced off Mattingly's helmet into Duke's hands. It's cool they found the ring, but there are many other things people left up there. There's even a toothbrush floating around somewhere. Mercury is already the tiniest planet in our solar system, not counting Pluto, of course, and the second densest after Earth, and believe it or not, it's actually shrinking and getting denser. For a long time, scientists thought Earth was the only planet with tectonic activity, but that all changed when the Messenger spacecraft flew by Mercury, giving us a detailed scan of the whole planet. In 2016, Messenger discovered these cool cliff-like formations called fault scarps. Since they're still relatively small, scientists think they're pretty new, suggesting that Mercury is still contracting 4.5 billion years after the solar system began. Around 10 years ago, Italian astronaut Luca Parmitano went through a near-drowning experience during his spacewalk due to a water leak that went unaddressed. Nobody knew how it happened, and why Luca ended up having water in his helmet. NASA was investigating the issue for months, but they were unable to determine the exact cause of the water entering Luca's helmet. We also might have just stumbled upon the mother of all water reserves, floating in space, and it's been hiding under our noses for at least around 12 billion years. As for its size, it's hard even to imagine. 140 trillion times larger than all the oceans on our home planet combined. This cosmic water world is orbiting around a large black hole known as a quasar, located 12 billion light-years away. Quasars feature supermassive black holes, spewing out colossal quantities of radiation. This one in particular is estimated to be 20 billion times heavier than our Sun, and carrying energy that could outshine 1,000 trillion of them. Here, in our cozy Milky Way, we're used to seeing water in ice form. This water reserve in particular seems to be in the shape of vapors. The important thing about this discovery is that there may be water everywhere in the universe. We just need to learn where to look. You might be surprised to learn that not all stars are hot to the touch. We used to think all stars were like our Sun, these blazing hot balls of fire, ready to melt anything in their path. Their cooler counterparts are called brown dwarfs. What makes them special is that they're too small to pull off the nuclear fusion that keeps stars like our Sun shining. They don't give off much light or heat, which makes them hard to see. These brown dwarfs are also split into different categories. There's this one group called Y-type stars, and they're the coldest, with a surface temperature lower than your average cup of tea. If you could reach out and touch one, you'd probably just feel a cozy warmth. Around 4 billion years ago, Uranus apparently switched places with Neptune. It's hard to imagine planets that big doing that, but this theory might solve the mystery of how our solar system came to be. We know that rocky planets formed after big collisions. Take our planet for instance. Around 4.6 billion years ago, things kept bumping into each other around the Sun until our watery Earth reached its final form. It also included one larger collision that blew up enough rock and gas for it to generate our moon. But when it comes to our larger solar system neighbors, Jupiter, Uranus, and Neptune, scientists still haven't got an answer. Standard models said it'd take forever for them to form, way longer than the solar system itself has been around. If this new theory is correct, it suggests that Uranus and Neptune came from this dense cloud of gas compacted around the Sun. Problem is, for the theory to make sense, they had to have swapped places at some point in history. Neptune is about 2.13 billion kilometers away, the farthest any planet can be in our solar system. Uranus is a bit closer, located at 3.5 billion kilometers. This new idea suggests that after they formed way closer to the Sun than they are today, their positions were altered. It could have either been because of many comets passing by over billions of years, slowly tugging the giant planets away. It's not a definitive answer to how gas giants were formed. It's more like a strong hunch, backed up by looking at a lot of numbers. Speaking of weird things found in our universe, what about this floating spoon that NASA's Curiosity rover took a picture of on Mars? As the machine was cruising around the red planet, it stumbled upon this oddly spoon-shaped rock during the summer of 2015. The rock has a handle and even throws shade on the ground. It's not a leftover utensil from some Martian picnic, but rather what NASA scientists call a ventifact. That means it's a rock that got sculpted by the wind. It's not the first time the Martian surface has delighted us with weird, windy sculptures. There was the face on Mars, a rat, and even jelly donuts. It's also possible that diamonds are raining down on over 1,900 exoplanets out there in space. Scientists found out that you don't need particularly hot temperatures for carbon to turn into diamonds, like it was previously believed. Up until recently, we only knew of Neptune and Uranus to potentially feature sparkling showers. Astronomers were onto this interesting phenomenon for about 4 decades, But these planets were hard to study. We've only had one space mission, Voyager 2, swing by for a peek. A lot of progress is being made, though, thanks to lab simulations. Neptune and Uranus are called the ice giants because their outer layers are filled with hydrogen, helium, water, and ammonia, what scientists call ice. And that gorgeous blue hue they have is due to the methane in their atmospheres. The beautiful diamondy phenomenon happens deep down, however. If we could visit, we would see that beneath the thick atmosphere, there are layers of very dense ice. And under all that pressure, chemical reactions are happening, possibly generating diamonds the size of a small town. We can't just dive into Neptune or Uranus with a diamond-seeking probe. Instead, the same conditions are being replicated in labs here on Earth, squeezing matter between diamond anvils and zapping it with lasers to mimic the extreme conditions. Under these circumstances, scientists managed to create artificial diamonds. Understanding how these rocks form down there could also explain why Neptune is hotter than it should be and why it's got such intense storms. These diamonds might also be the key to unlocking the mystery of Uranus and Neptune's weird magnetic fields. If we compare it to our planets, it doesn't behave the same way, so there may be weird things happening under the surface to affect the magnetism. NASA's plans include sending a new probe to Neptune or Uranus in the next decade. With the planets aligning just right in 2030, it's the perfect time to explore these potentially diamond-filled worlds up close. Planet Kepler 78b is another weird cosmic discovery. It's a hot, molten world that's doing laps around its star in record time, once every 8.5 hours, and pretty close, less than 1.6 million kilometers away. Hot environment aside, if we could set foot on its surface, we'd notice its sun being 80 times larger on its sky than the daily view we have here on Earth from our star. If we apply what we know so far about how planets form, this little guy shouldn't even be there. Specialists still don't have a clue how it came to be, or how it ended up where it is now. What we do know is that it will disappear soon. Sort of. Since it's so close to its start, this scorching, hot planet is going to collide with it in a couple of billion years. Sounds like a lot, but it's a cosmic jiffy. What's similar between our planet and Kepler 78b is the density. Sure, it's about 20% bigger than Earth and weighs almost double, but it's got that same solid interior. There's no possibility of it forming any closer to its star and simply moving away with time. It also couldn't have been born much further away and migrated in. Any movements inward would have been unstoppable, and it would have also collided with the star. This may not be a particularly groundbreaking discovery, but chances are you've never thought of it. There may be space dust in your hair right now. Every day, loads of outer space matter comes raining down on Earth. Sometimes we get flashy objects, like when a meteor turns into a meteorite by crashing down to the ground. But most of the time, it's quieter. This cosmic material drifts down through the atmosphere, landing softly as what we call space dust. It may not sound like much, but it does add up to around 14 tons every single day. This space dust contains tiny fragments of rock and metal, broken off from asteroids and comets during big collisions. These particles are very small. You can't see them without special tools, but every time you step outside, some of it might land in your hair. Scientists were looking at a list of gas clouds when they saw something strange. 5 groups of blue stars that are not quite a galaxy, and not a known type of star cluster either. These groups of stars are called blue blobs, and they're located in the Virgo galaxy cluster. Now, the big question is, how did these blue blobs form if they don't have any nearby parent galaxy where they could form? Scientists realize there are some heavy metals present in these blobs. Generally, when stars are born, they create heavy elements called metals. These metals are essential building blocks for new stars. In big galaxies, many stars form over time, and as a result, more metals get created too. These heavy metals in the blue blobs were a clue that the stars in these blobs were formed from gas that was stripped from a larger galaxy. Think of it as a piñata. The candy is the gas, and the piñata is this bigger galaxy. The blue blobs are the leftover candy that was scattered around. Wow! Didn't expect to get hungry while talking about stars. How did the gas get stripped away from the bigger galaxy anyway? There are two ways. When galaxies pass by each other, their gravitational attraction can cause gas to be pulled away from one galaxy and into the other. This is called tidal stripping, and it's the first way these blobs can happen. It's like when two magnets attract and pull metal objects toward each other. Another way is ram pressure. This happens when a galaxy moves through a cluster of hot gas at a pretty high speed. The gas in the cluster can push against the gas in the galaxy and force it out back, similar to a car pushing air out of the way as it drives, and you lose your hat in a strong wind. As time goes by, these stars in the blue blobs will keep on moving apart. Eventually, they will form smaller clusters. Have you ever seen pictures of Earth taken from space? They're amazing! But have you seen the one with two blue blobs of light? The first blob of light you see here is a large lightning strike in the Gulf of Thailand. It's rare to see lightning from space because of all the clouds, but this one was so huge it lit up the clouds around it like some kind of a brilliant ring. How cool is that? The second blue blob of light is a bit different. We're looking at the reflection of the moon's light on our home planet. The moon actually reflects the light coming from the sun onto the Earth, and when that light goes through the Earth's atmosphere, it creates a big blue blob with a seawork-affection swow al texas surgiu. Lain kasentin. It's like a shiny blue hat our planet is wearing. It's similar to the reason why the sky is blue during the day. When sunlight enters Earth's atmosphere, gases and particles in the air scatter it in all directions. Blue light has the shortest and smallest waves, so it gets scattered the most. And that's why we get to enjoy a beautiful view of a clear blue sky. The same thing actually happens to the light coming from the moon when it reflects off the Earth and goes through the atmosphere. The blue light waves get scattered the most, making the moon appear blue in the photo. Speaking of unusual stars, there's one in the Centaurus constellation called Lucy. It looks like a tiny white dwarf, but it's actually very dense. There's a mass of the entire sun squeezed into an object only a third of the size of our home planet. That's like stuffing a whole watermelon into a golf ball. Lucy is also incredibly cool. Its core temperature is almost 12,000 F, 11 times 12 F. This may sound hot at first, but for comparison, our sun is about 27 million F. And the best part that makes Lucy so special is the diamond at its heart. Its carbon core has crystallized into a massive diamond that's 10 billion trillion carats in size. It's hard to even imagine how big it is. Scientists found out about this awesome diamond by listening to the star's vibrations, which is like a star's heartbeat. And after they discovered Lucy, scientists found some other stars with crystallized cores and massive diamonds the size of Earth, too. Our universe is like a giant jewelry store. Most of the astronomers from the Northern Hemisphere are familiar with the star named Vega. First, it's brighter than expected, but if you could take a look at it from a different angle, you'd see this star is actually squashed. It has a specific oblong shape because it rotates at a high rate. It spins once every 12.5 hours, which throws the material out around its equator. This material then cools and darkens, and forms a dark, mysterious halo around Vega. When stars reach the end of their lives, they often explode in a dazzling supernova, getting brighter and brighter before they finally fade away. But one supernova, IPF 14 Echelles, decided not to obey the rules. It started to fade away, like most other stars. But then, when everyone expected it to be gone, it suddenly came back to life and brightened up again. And not just once, it kept fading and brightening at least 5 times in a row. Scientists were so surprised to see this. When they measured the light from the supernova, they found it was evolving 10 times slower than other stars. It was aging way more slowly too. When it looked 60 days old, it was actually 600 days old. It could be even older, because scientists had recorded another supernova in the same spot almost 70 years ago, 1954. There are some theories as to how it could have happened. Maybe the supernova was bumping into some surrounding material and then making it glow. Or maybe it was a giant star that was shedding material all the time to prevent, or at least postpone, its own collapse. At first, it may seem like you're looking at a simple variable star here, my Camelopardalis, but when astronomers looked more closely, they realized it was a pair of stars. The two stars are moving around each other at really high speeds, and their atmospheres are starting to mix because they are so close. People believe this example is the start of a union between two stars. In the end, the two celestial bodies, which already weigh 32 and 38 solar masses each, will join together to make a gigantic one with more than 60 solar masses. Scientists have thought for a long time that this is how super big stars form, but they've never really seen it happen. The universe is 13.8 billion years old, and from what we can see, one mysterious star, HD 14283, could be 14.4 billion years old. Something's not right here. This star has all the chemical signs of a second-generation star, which is a star that formed from gas and dust after the first generation of stars exploded. This star, sometimes called Methuselah's star, is 190 light-years away. Its brightness, distance, and composition help us figure out how old it is. At least 13.2 billion years old, while the age of 14.4 billion years is probably put there as a potential range. Even if it's younger than the universe, or is it? It's still by far the oldest star near us. Let's not forget the one with the tail either. It's called Mira. Sometimes it's bright and other times it's faint, making it a bit of a tricky one to spot in its constellation, Cetus. Sometimes it's one of the brightest stars up there, while other times it is one of the fainter ones in its constellation. It's the system with two stars, a red giant and a white dwarf. The red giant used to be like our own sun, but now, as it's closer to its end, it's shedding its outer layers into space. And Mira has a comet-like tail too. As the red giant sheds its outer layers, it creates a stream of gas and dust that follows the stars as they move through space. Back in the day, from 774 to 775, Earth got hit with a megablast of radiation. This crazy burst of energy left its mark. Tree rings from that year show way too high levels of radioactive stuff. But what exactly caused it? Scientists are inclined to think that the reason was a solar flare. Some folks think maybe a massive supernova caused the radiation blast, but astronomer Phil Plait says that if that had been the case, it would have had to be less than 1,000 light years away and would have been crazy bright. But there's no record of that happening. No bright, shiny Death Star in sight. Some folks think maybe a massive supernova caused the radiation blast. Scientists ruled out a bunch of other possibilities. At first, they considered that it was a smash-up between neutron stars, or a neutron star and a black hole. These types of crashes produce a super quick blast of gamma rays without any light show, which lines up best with the evidence. But these kinds of collisions are super rare. Plait thinks it's kinda unlikely that this is the answer. He figures we should only see one of these events in our galaxy about once every million years. So having one just 1,200 years ago seems pretty wild. Scientists are seriously worried about these rare events. If one happened closer to Earth, it could seriously mess up life on our planet. Even if it was thousands of light years away, a similar event today could cause chaos with all the fancy electronic systems we've come to rely on. So, it's a good thing those gamma ray bursts are so rare, because if they were more common, Earth might be in for a rough ride. You may think that if our planet could withstand mega radiation blasts, it can easily withstand something less frightening. Let's say grasshoppers. Sorry to say that, but it's not exactly true. Back in 1874, during a hot summer in Kansas, things took a strange turn. Grasshoppers, or should I say locusts, invaded the Great Plains like nobody's business. They came down like a storm, blanketing houses, trees, and even poor trains passing by. These bugs were on a mission to cause chaos. Farmers had to scramble to protect their wells and just about anything else worth saving. Locusts landed everywhere, wreaking havoc on everything in sight. Even poor sheep lost their wool. Locusts even stripped paint off wagons and handles off pitchforks. This is how destructive they were. Livestock tried to fight back by eating them, but there were just too many of these insects. That year, those critters caused about $200 million in crop damage. The locust invasion was so tough, even the US Army stepped in to help. In the end, locusts began to disappear, sparing the plains from further devastation. Natural disasters can be even more unexpected than radiation blasts from space and locust invasions. Check this out. Back in June 2017, a reindeer herder up in northwest Siberia was minding their own business when they suddenly heard a crazy loud blast and saw smoke shooting up from the ground. If that happened to me, I'd need to change my pants, sorry. Later on, they found this huge hole that was like 7 meters wide and nearly 20 meters deep and was surrounded by chunks of ice and dirt. It turned out that there were over 17 such black holes in the area. They were filled with peaty water and shrouded in mystery. Some folks thought those were sinkholes. Others were sure they were left by top-secret device tests or even a bunch of meteorites. Now, the latest idea is that these holes are actually craters caused by the Arctic warming up and melting the frozen ground. The theory states that as the ground thaws, gas pockets trapped beneath the surface burst through, creating such dramatic holes. Apparently, these eerie craters have been showing up in specific spots in Siberia, where ancient geological faults have been leaking out hot natural gas for ages. Combine that with some leftover methane from old lake sediments, and you've got a recipe for some explosive surprises as the planet heats up. Not scared yet? Alright, maybe you're afraid of darkness, huh? If so, you wouldn't like it back in 536. It's the year when the world went through a crazy 18-month period of darkness. A mysterious fog covered Europe, the Middle East, and parts of Asia, blocking out the sun and causing chaos. It was like the Dark Ages, but for real. It turns out that the main culprit behind this fog was a volcanic eruption in Iceland. This eruption spread ash across the northern hemisphere, causing temperatures to drop and crops to fail. People were freezing and starving. It was a mess. Historians from back in the day even talked about how weird it was. The sun looked like the moon, summers were freezing cold, and even China had summer snow. It was all because of the volcanic ash blocking out the sun. And to make things even worse, this period of darkness sparked the beginning of the bubonic plague in 541. Talk about a rough time to be alive. Let's go back to Siberia real quick. Back in 1908, way out in the wilds of Siberia, an asteroid dropped in for an unexpected visit. Today, we know it as the Tunguska asteroid, but it didn't get its name instantly. Local folks only caught a glimpse of the show, a bright fireball streaking across the sky, followed by a massive boom. Trees went flying, fires blazed, and animals weren't too happy about it either. But since the area was so remote, not many folks took notice. For almost 2 decades, nobody bothered to check out the Tunguska site. People had too much on their plates back then. But then, scientists finally made it out there and found evidence of the asteroid's shenanigans. Later in expeditions, they found some spacey microparticles. Fast forward to now, and NASA has a whole planetary defense thing going on. They even sent a mission to test out asteroid deflecting tech, because who knows when the next cosmic rock will come knocking on our door, right? In the middle of the 19th century, there was one more epic solar storm called the Carrington event. It may not sound like a big deal to you, but it had pretty tough consequences. The next day after the storm, Earth was hit with this insane geomagnetic storm that threw telegraphs off the rails and brought auroras to the tropics. and it's the place where they normally never show up. Turns out, all this space weather madness started with weird stuff happening on the sun's surface, like sunspots. From these spots, solar flares and other crazy electromagnetic stuff can pop out and mess with our technology. Massive solar storms like this one can shoot out from the sun at speeds of up to 2,196 kilometers per second. They can contain billions of tons of solar material, complete with a sassy little magnetic field that loves to mess with Earth's magnetic field when they meet. Now listen closely. We're getting close to the next solar maximum in 2025, so it's a good time to check out the history of the worst solar storms like the Carrington event. And take notice. Imagine if a similar storm hit today, an internet apocalypse, anyone? Businesses would be sent offline, and we'd be facing some serious damages. Luckily, these mega solar storms don't happen very often. But hey, space weather is tricky to predict, so who knows when the next one will hit? For decades now, scientists have been discovering new planets outside our solar system. By 2023, we've found more than 5,000 of them, and many of these exoplanets could potentially even have life. Now, if you're ready for a wild ride through space, let's find out what potentially habitable planets we've discovered in the last few years. LP899b and LP8909c. Buckle up, because we're heading to LP899. A red dwarf star located a whopping 105 light-years away from Earth. This star is quite cool compared to our Sun, in terms of temperature, of course. It has a temperature of about 4,700 degrees. Now, this little guy may be small, but it's packed with surprises. For example, 2 exoplanets orbiting around it. Moreover, both of these planets are likely terrestrial, meaning they are rocky, just like Earth. First up, we have LP899b, which was discovered in 2022 using the TESS telescope and later confirmed by the Speculoos telescope. This planet is a super-Earth, weighing in at about 13 times the mass of our own planet. It's also slightly bigger than Earth, with a radius about 1.3 times larger. And if you thought Mercury's orbit around the Sun was quick, just wait until you hear about LP899b. It takes about 3 days to complete one lap around its star. Imagine falling asleep in freezing winter and waking up in hot summer. But the real showstopper here is LP899c. This one was discovered by the Speculoos telescope. It's a bit further out from the star and takes a leisurely 2.5 times longer to orbit than LP899b. It's also a bit larger than Earth. But its real claim to fame is its location within the habitable zone of its star. That means it could potentially have liquid water on its surface and a climate suitable for life. Now, this planet becomes a prime candidate for studying its atmosphere using the James Webb Space Telescope. But hold on, it's not all sunshine and rainbows for LP899c. It's also really close to its star, meaning it's full of radiation that could potentially make it less habitable. And to top it off, it's tidally locked, just like our moon. That means one side of the planet is always facing the star and is incredibly hot, while the other is always in the dark and really cold. Scientific models suggest that this planet could be more like Venus in terms of its atmosphere and climate, and Venus isn't known for being human-friendly. But despite these challenges, LP899c is still a fascinating exoplanet worth studying further. Who knows what secrets it may hold? Let's move on to the next candidates. GJ1002b and GJ1002c. An international team of scientists led by researchers at the Instituto de Astrofísica de Canarias has found 2 Earth-like planets, just 16 light-years from our own solar system. They both orbit a red dwarf star called GJ1002. Our Sun is a yellow dwarf, which means that GJ1002 is much cooler and fainter than our own Sun. But that's okay. Both planets are very close to its star, so it shouldn't be too cold or dark on them. These planets, called GJ1002b and GJ1002c, are both in the habitability zone of their star, meaning that they could potentially support life. Also, both of them have masses similar to that of Earth. GJ1002b is the inner planet and takes about 10 days to orbit its star, while GJ1002c takes a little over 21 days. These planets are great candidates for studying their atmospheres and could even be targets for future missions to search for signs of life. The most important thing is that these two planets could potentially support life, and that's pretty cool. Plus, the fact that they're located so close to us means that we might be able to visit them someday. Well, maybe not us personally, but you know. And maybe one day, we'll even find some extraterrestrial life on one of these planets. Now that would be out of this world. But moving on to the next one. Kepler 1649c. Kepler 1649c, also known as the Lost Exoplanet, was rediscovered in 2022 by scientists using data from NASA's Kepler spacecraft. This exoplanet is located about 300 light-years away from Earth and orbits a small cool star called Kepler 1649. It's about the same size as Earth, and just like the previous ones, is located in the habitable zone of its star. Initially, the data about this planet was discarded. A special computer program called RoboVetter, written to automatically sift through the volumes of Kepler data, labeled this candidate as a false positive. In other words, the program thought it was just some kind of an error or interference. Fortunately, the researchers double-checked such things, and when rechecking the data, they managed to rescue poor Kepler 1649c. Now we know that this is a terrestrial planet, just like Earth, and if it really does contain water, there could be even life there. But don't pack your bags just yet. There are still many unknowns about Kepler 1649c. For example, we don't know what its atmosphere is like, or what kind of surface it has. It's also possible that the planet is tidally locked, just like LP899c. That would be unpleasant. That's why Kepler 1649c is definitely worth further study. Maybe it turns out to be a perfect place for us to set up a vacation home in the future. Just make sure to bring plenty of sunscreen since the planet is pretty close to its star, and things could get pretty toasty. Kepler 1638b. This exoplanet is located about 5,000 light-years from Earth in the constellation Cygnus. It's also located in the habitable zone of its star. It was discovered in 2020 by the Kepler spacecraft through the process called transiting. They basically take a bunch of photos of the star at different times. After that, the programs analyze these photos and look for small spots and dots on them. These tiny dips in brightness may mean that a planet was passing by the star. Kepler 1638b is a bit of an oddball compared to most exoplanets we've found so far. It's about 4 times the mass of Earth and has a radius about 2 times that of Earth, making it a super-Earth exoplanet. Its orbital period is about 260 days, which is quite close to our Earth, and that's great. Finally, at least somewhere winter and summer will flow normally. Kepler 1638b could also have some liquid water there. That's why it's also a good candidate for further study to see if it could potentially support life. Let's hope that we'll find out more about this planet in the future. And finally, the last one. Kepler 438b. Kepler 438b is an exoplanet located approximately 640 light-years from Earth in the constellation Lyra. It was discovered in 2015 by the Kepler Space Telescope. One of the most interesting things about Kepler 438b is its size and location. It's about the same size as Earth, and also orbits within the habitable zone of its star. But there are a few catches. For one, Kepler 438b orbits around a red dwarf star, which are known for their high levels of solar radiation and flare-ups. This could make the surface of the planet too hostile for life as we know it. In addition, Kepler 438b has a much shorter year, only around 35 Earth days long. This could lead to extreme temperature fluctuations on the planet's surface, but maybe it's home to some hardy extraterrestrial life forms that have adapted to its unique conditions? Or maybe not. Either way, it's definitely worth keeping an eye on. This is a small list of exoplanets that we've discovered in recent years. Now, with the use of new technologies, we'll be able to find new exoplanets much more often. Let's hope